Section 8.1 talks about testing differences between means when we have the population standard deviation for two samples that are known. So it says in this section, we're going to learn to test claims comparing. Give me 1 second here, guys. Let's see. Close that up. Sorry about that. Okay, so let's see. It says in this section, we will learn to test claims comparing the means of two different populations using independent samples. For example, consider the populations of female and male students at STC. Suppose we wanted to compare the mean GPA of the two populations. The population mean GPA of all male students can be represented by mu1, which we have right here, and the population GPA of all female students can be represented by mu2. And if you take a sample of N1 male students and compute the GPA, the average GPA of the sample, we can label it as X1 bar. And if we take a sample of N2 female students and compute the average GPA of the sample, we can label it as X2 bar. It's typical to test a claim concerning the difference between the parameters in the two populations, not the values of the parameters themselves. So this part right here, this next part is important. It says, assume always there is no difference between the population means, so that mu1 and mu2 are going to be equal. Okay, so it says here, for a two-sample hypothesis test with independent samples, the null hypothesis HO is a statistical hypothesis that usually states that there is no difference between the parameters of the two populations and always contains the symbols less than or equal to, or greater than or equal to, right? Remember, we always said the null hypothesis always has to have that equal to part. And the alternate hypothesis, HA, or HA, is the statistical hypothesis that is true when HO is false and always has the symbol either greater than, not equal to, or less than. So it says sample null and alternate hypothesis when comparing two means. So HO is going to be saying that either mu1 is going to be equal to mu2, so the HA would say that they're not equal to. Right here, it'll say that mu1 is going to be smaller than or equal to mu2, so then the alternate is that it's bigger, or that mu1 is bigger than or equal to mu2, so the alternate is that it's smaller. Okay, so it says a two-sample z-test for the difference between means. So a two-sample z-test can be used to test the difference between two population means mu1 and mu2 when these conditions are met. So number one, both population standard deviations for each population are known. Mu1 and mu2, sigma 1 and sigma 2 are known. Samples are random, samples are independent, populations are normally distributed, or both N1 is bigger than 30 and N2 is bigger than 30, and the test statistic X bar 1 minus X2 bar, the difference in the sample means, is a normal distribution, and this is how we find our standardized test statistic. So if you remember before, we used to do, a lot of times it was this formula. It was like X bar minus mu over sigma divided by the square root of n, right? So when we have a two sample, the formula is a little bit more complex, okay? So what I'm going to do is I'm going to show you all how to do this on our calculator. Guys, I want to point out, doing this on the app is going to be exactly the same way, okay? It'll be exactly the same way. So what I'm going to be doing this, and I'm going to kind of walk you through, I got 3 problems to do here. I'm going to walk you through the process so that you can see how it's going to work. And but again, the process, whether I'm doing this on a calculator or whether I'm doing this on my calculator app, will be exactly the same. Okay, so let's go through the problem here and see if we can't figure this out. Guys, I took these problems directly from my math lab, and I did a whole lot of copying and pasting, so the process is going to be the same when you're doing your homework. Okay, so it says to compare the dry braking distances from 30 to 0 miles an hour for 2 makes of an automobile, a safety engineer conducts braking tests for 35 automobiles for make A and 35 automobiles for make B. It says the mean braking distance for make A is 41 feet. Okay, so my mean is 41. Assume that my standard deviation is 4.9 feet. The mean braking distance for make B is 43 feet. Assume the population standard deviation is 4.6. Okay, it says at alpha is equal to 0.10, can the engineer support the claim that the mean braking distances are different for the two makes of automobiles? Assume samples are random and independent and the populations are normally distributed. Okay, so the way I have this here, guys, exactly the same way in my math lab. So it says identify the claim and state HO and HA. Okay, so look what it's telling me right here. The claim that the mean braking distances are different for the two makes of automobiles. Okay, so I'm going to do it like this. mu1 and mu2, and it says that they're different. Well, if they're different, that means that they're not equal to. Okay, this is going to be for make A. This is going to be for make B. This here is my claim, right? So when I start looking at my choices A, B, C, and D, it says the mean braking distance is different, right? So I'm going to choose part A, okay? Now, when we're working on this part here, this is my claim, right? What's the opposite of saying that something is not equal to? Saying that they are equal to, okay? Again, this is for A, this is for B. So this is going to be my null hypothesis because it has the equal to part. And the top one is going to be my alternate, right? Boom, there we go. Okay, so my null has the equal to, the alternate has the not equal to. So I'm going to come back over here and I'm going to say, what are HO and HA? Well, HO is that they're equal to, and HA is that they're not equal to, right? Okay, so now when I get to part B, it's asking me to do a whole bunch of steps here. It's asking me to find the critical value, identify the rejection regions. Okay, so we're going to do that right now. So first thing is, because my alternate says that they're not equal to, this is telling me that we're going to have a two-tailed test, right? Okay, so we're going to have a two-tailed test, and if my alpha in this case is 0.10, then to find those rejection regions, I got to take alpha and divide it by 2, and that's going to give me 0.05, okay? So what I'm going to do here is I'm going to have a little region here. The area underneath that curve is going to be 0.05. We're going to have a region here. That's going to be 0.05. And now what we need to do is we need to find these two critical values. Remember, one of them is going to be negative, and one of them is going to be positive, okay? So I'm going to take my calculator right here. I'm going to turn it on. There we go. The way I'm going to find this is I'm going to go second vars. I'm going to go down to inverse norm, and I'm going to type in 0.05. Okay? And so if you notice, I'm coming up with negative 1.6448, all that kind of business, right? I want you to notice that the directions, they are actually asking me to go to 3 decimal places, okay? So, oops, I didn't mean to turn this one on. Let's see if I can get rid of it. There we go. So 3 decimal places, negative 1.645. Okay. So negative 1.645, positive 1.645, right? And these are going to be my answers here. And look what it says. Use a comma to separate. So you're going to type in your answer here. You're going to type in negative 1.645, comma, put a little space there. Oops. Positive 1.645, right? Okay. Now, it is going to probably ask you look what it says here. Second part says, identify the rejection regions. Okay, so remember, these are my rejection regions. This is my fail to reject region, right? So if I'm identifying my rejection regions, the rejection region is when Z is going to be smaller than 1.645 and when z is going to be bigger than 1.645, right? Okay. Now, there's a second part here. We're going to find that standardized test statistic, okay? So guys, if you come back up here, and it gives, we have this rowdy old formula here, okay? I don't want to use that formula simply because it's, it's not super hard, but using the calculator is going to be much easier, okay? So I'm going to write down a couple of things. We have two cars, or two models, right? We have A and we have B, okay? So let's see. We have 35 models for A. So in the first part, I have 35. We also have 35 for B, okay? Let's see, what else do we know? We know that for A, my X bar, so I'm going to call it X1, right, is 41 feet. And we have a population standard deviation of 4.9. So my sigma 1 is 4.9, okay? For part B, my X2 bar was 43 feet, and let's see, our population standard deviation was 4.6. Okay. All right, so we have those pieces of information. I'm going to take my calculator now. I'm going to clear this out. I'm going to go to Stat. I'm going to scroll over till I hit Tests, and I'm going to go to number 3. It's a 2-sample z-test, okay? And you want to make sure that you're under the stats part, okay? So I want to make sure I'm under the stats part. We are, okay? So look, the first number is asking me for my sigma 1. Sigma 1 is this number right here. Okay, so sigma 1 is 4.9. So 4.9. Sigma 2 is 4.6 under my column B. Okay. X1 bar is going to be 41. My N1, which is under A, because I'm looking at for the first part, 35. Okay. My X2 bar is 43. And my N2 is also 35. Okay. And then we said that this was a two-tailed test. So we're going to say that mu1 is not equal to mu2, so we're on the right spot. And now I'm going to hit calculate. And we're going to look for the z-value that we came up with. So the z-value that I'm coming up with is negative 1.76. And I'm going to see, does it ask me to write 1 decimal place, 2 decimal places? Ask me to write here 3 decimal places. Okay, so negative 1.761. Okay, so right here I'm going to write in negative 1.761. Okay, so now what I want to do, I'm going to come back. Let me see, where is my picture? Didn't we had a picture somewhere, didn't we? Ah, yes, it is right here in front of me. Oops. Okay, so let's take a look at this value, negative 1.761. This one right here. If this is negative 1.645, negative 1.761 is going to be right here. So which region did we fall into? Well, we fell into the rejection region, right? So I'm going to click B because the standardized test statistic falls in the rejection region, right? Okay, so now that we got to that part, okay, we fell in the rejection region. Now we have to do part E. So the first part is asking me is what percent significance, right? So what they mean by that is when I came back to my original problem, and I'm going to erase some of this because I did write all over it. Okay, so I'm just cleaning this part up now. But look what it said here. At alpha is 0.10. So this is saying at 10% significance. And now we got to figure out the next part. So guys, before I do that, we're going to figure out which was our claim. Okay, so we said our claim was the alternate, right? And we were rejecting the null hypothesis, okay? So we knew our claim was the ha, and we were rejecting the null hypothesis because we fell in that rejection region. So I'm going to pull up my little form here, right? This is the same one we used the other day. So let me do this just to kind of keep things separated. You gotta keep them separated. I knew y'all knew I was going to say that. Okay. So what did we say? We said our claim was our ha, and we rejected the null hypothesis. So we're going to say there is enough evidence to support the claim. So I'm going to come back here, and we're going to say there is enough evidence to support the claim that the distance, that the mean braking distance for make A automobiles is what? And we said it was different. So right here, I'm just going to write different. And that's all you got to do. Okay. So I have a total of 3 problems here, guys. Let's keep going. I'm hoping that as we do this, it gets a little easier or you kind of pick up on the idea, but I am going to walk you through them. Okay. So let's take a look at number 2. Number 2 says an energy company wants to choose between 2 regions in a state to install energy producing wind turbines. A researcher claims that the wind speed in region A is less than the wind speed in region B. Okay, so I'm going to stop right there. Look what they're saying. The region A, so let's call this one A, let's call this one B. Region A is less than. So this is less than for region B. And that is our claim. So what's the opposite of saying something is less than? Saying that it is greater than or equal to. Okay? So now we're going to figure out which is the ha. The top one is the ha, and the bottom one is the ho, right? This is my null because it has the equal to, and this is my alternate because it doesn't, right? Not necessarily because it's the claim, but because it doesn't have the equal to part. Okay, so it says to test the 2 regions, the average wind speed is calculated for 90 days in each region. Okay, so I'm going to do it like this. We're going to go for region A. We're going to go for region B. We know that in A it's 90, and the number of days in B it's also 90. Okay, the wind speed. The mean wind speed in region A is 13.7, so my x1 bar is 13.7. Assume the population standard deviation is 2.7, so my sigma 1 is 2.7. It says the mean wind speed in region B, so my x2 bar is 15.2, and my sigma is 3.2. Okay. Now it says at alpha is 0.05. Can the company support the researcher's claim? Okay, so now it says identify the claim and state the HO and the HA. So look what we're saying. We're saying that region A, the wind speed is less than region B, right? Because it says right here, the wind speed in region A is less than the wind speed in region B, so that's going to be choice B, right there. Okay, now it says let region A be sample 1, let region B be sample 2, identify. Okay, so HO, look what we're saying HO is. We're saying that HO is going to be greater than or equal to. So guys, when you're doing this, you're going to have a little drop-down menu, and you're just going to select greater than or equal to. Oops, wrong one. For my HO, greater than or equal to. And my HA, it's going to be less than. Okay. Now, the next thing we're going to do, we're going to find our, oh, come on, my pen is freezing up again, guys, sorry. There we go. We're going to find our critical value. So look what we have here. We have alpha is 0.5. So the first thing I'm going to do is I'm going to look at my alternate hypothesis. It's pointing to the left. This is telling me that this is going to be a left-tailed test. Okay, so my alpha is 0.05. So We're going to have a little region here. This is going to be 0.05. Okay. And now we're going to try to find this critical value here. Okay. So remember how I'm going to do this. I'm going to take my calculator again. I'm going to turn it on. Let me quit this. Or clear it. There we go. Okay, so I'm going to go second vars, scroll down to inverse norm, type in 0.05, close it off, and again, I'm coming up with negative 1.644 or 645, and what does it ask me to do here? How many decimal places? It's asking me again for 3 decimal places, negative 1.645. So right here, I'm going to type in negative 1.645. Okay, so remember, this is my rejection region. That's my fail to rejection region. Okay, so look what it's asking me here. It's saying, what is the rejection region? When Z is what? Less than that number, right? So I'm going to pick C, and I'm going to type in negative 1.645. Okay, so now we're going to find our standardized test statistic. Okay, guys, the way we're going to do that, we're going to use this information right here with our calculator. So I'm going to get my calculator going. I'm going to clear it out. I'm going to hit stat. I'm going to scroll to tests. I'm going to go down to a 2-sample Z-test. Okay, and I'm going to just start entering in my information. So sigma 1 is 2.7. 2.7. Sigma 2 is 3.2. Okay. X1 bar is a 13.7. Okay. My N1 is 90. X2 bar is 15.2. My N2 is also 90. Okay. Then now we got to figure out, was this a left tail, right tail, or two-tail test? Didn't we say this was a left tail test, right? So look what we're saying, that mu1 is smaller than mu2, right? So when I come back over here, if you look here on the left, mu1, so we're going to click this one, smaller than mu2. I'm going to go down, I'm going to hit calculate. Okay, so now I'm coming up with a Z value. Okay, so I see it there, it says negative 3.3987, all that kind of good stuff, right? So first thing I'm going to do, I'm going to come back here, and notice they're asking me to round to 2 decimal places. So let's go ahead and do that. If we go to 2 decimal places, my Z value would be a negative 3.40, right? So right here, I'm going to say this is a negative 3.40, okay? So now, we're going to figure out, okay, where would this number fall on my number line here? So remember, this number here is that negative 1.645. So wouldn't negative 3.40 be even further to the left? 340, I'm sorry. Okay. So we fell in our rejection region, didn't we? Okay, so we're going to say now that we are going to reject the null hypothesis, right? So right here it says, decide whether to reject or fail to reject the null hypothesis and interpret the decision in the context of the original claim. So you're going to select here, and we're going to say we're going to reject the null hypothesis, right? Okay, so before I answer this piece of it here, I'm going to come back and I'll say, okay, which was my claim again? Our claim was our alternate, wasn't it? Okay, so my claim, my claim was my alternate. Okay, so our claim was our alternate, and we are rejecting that claim. Okay, so I'm just trying to zoom in a little bit. Okay, so I'm going to come back to my little cheat sheet again. Here we go. So my claim was my alternate, and we're rejecting the claim. We're going to say there is enough evidence to support the claim. So I'm going to come back here. There is enough evidence at 5% to, I already forgot what I was saying, to support the claim, right? Where are we? Here we go, to support the researchers claim that the wind speed in region A is what? Come back over here, is less than, right? Less than the wind speed in region B, okay? And then you're done. All right, so I'm hoping the second one seemed a little bit better. And so we do have one more, so I'm hoping this one here is gonna be even more better. That's not a real word, guys, it's just better. Can't say more better. All right, so again, let's go through this problem and we'll be done with 8.1. Okay, you want to buy a washing machine and the salesperson tells you that the mean repair costs for Model A and Model B are equal. Okay, so they're saying, so remember we're going to have Model A and we're going to have Model B. Okay, so look what they're saying. For Model A, they're going to be equal to Model B. This is our claim, right? So what's the opposite of saying something is equal to? Saying that they are not equal to. So this is my null hypothesis, and this is my alternate hypothesis, right? Remember, my null always has the equal to part. Okay, okay, so now it says you researched the repair costs, and the mean repair cost of 30 Model A washing machines is $214. Okay, so let's do it like this. We're going to have two models. We have Model A, we have Model B. How many for Model A are we looking at? We're looking at 30 of them, and we know that the mean repair cost is $214. So my X1 bar is $214, and our standard population deviation is $16. Okay. Then it says the mean repair cost of 23. So that means that my N2 here is 23, is my X2 bar, their mean cost is 222, and my population standard deviation is $24. Okay. At alpha is 0.01, so at 1%. Can you reject a salesperson's claim, assume the samples are random and independent, and state the populations, and the populations are normally distributed, complete parts A through E. Okay, so what is the claim? Here it is. The claim is that they are equal. So when I look at part A, the claim is that they are equal to each other. Boom. There we go. Okay, look what it says. Let mu1 be the mean for cost A and mu2 be the one for, what's my HO and my HA? So look, we have it right here, right? Here's my HO and here's my HA. So it's right there in front of me. So I'm going to look for the one where it says HO says that they're equal to and HA says that they're not equal to. That would be choice D, okay? All right. Now, part B says we're going to find the critical values and identify the rejection regions. So if you remember here that our alpha was 0.01, and since my alternate says that they're not equal to, guys, this is going to be a two-tailed test. And if we have a two-tailed test, when my alpha is 0.01, we need to find alpha divided by 2, which is 0.005. Okay. So now what I'm going to do is that my alpha here, oops, yes, we're good. My alpha here, this is 0.005, this is 0.005. Okay, what we want to do, we want to find those two critical values, right? This is going to be my negative Z0 and my positive Z0. Okay, so we're going to have two of them. So how am I going to do this again? I'm going to get my calculator. I'm going to turn it on. Here we go, let's clear. We're going to go second vars. We're going to scroll down to inverse norm. And we're saying the area to the left is 0.005. Oops, forgot a 0.005. Okay, hit enter. And I'm coming up with, it's asking me to go to 2 decimal places. So in this case, a negative 2.58. So right here, I have a negative 2.58 and a positive 2.58. Remember what this means? This is my rejection region here. This is my fail to reject region here. So it's asking me, when are we going to reject? We're going to reject anytime we're to the left or to the right. So I'm going to choose part A, and I'm going to say the first number here is going to be that negative 2.58, and the second one is going to be the positive 2.58. Okay. All right. So now we're going to do part C. We're going to find that standardized test statistic. Okay, so guys, in order for me to do this, I need to use this part right here. So let me get my calculator. Let me move this over. Let me clear that out. Okay, I'm going to go to stat. I'm going to go to test. I'm going to go down to a 2-sample z-test. Okay, I'm going to stick here with my stats. Okay, so what's my sigma 1? 16. Okay, what's my sigma 2? 24. Okay, what's my x1 bar? 214. My n1 was 30. Okay, my x2 bar was 222. And my N2 was at 23. And then we said this was a two-tail test, right? So that means that mu1 and mu2 are not equal to. And then I'm going to hit calculate. And I want you to look at the z-value that I'm coming up with. It says negative 1.381 if I round to 3 decimal places. So my z is negative 1.381. I'm going to see what are they asking me to do here. They're asking me to go to just 2 decimal places. So I would say z is a negative 1.38. Okay. So now that we're at that negative 1.38, we want to figure out where does this number fall in this picture. Okay. So I'm going to come back over here. So remember, this is at negative 2.58. This is at positive 2.38. We have a negative 1.38. So somewhere right about here is that number. What region did we fall into? We fell in the fail to reject region, right? So now, look, if you can see fail to reject region, we're going to choose part D because the standardized test statistic is not in the rejection region, right? Okay, now we're going to come back and we're going to answer our question. So first thing I want to figure out one more time is which was my claim. My claim was the null, okay? So, and you might say, how do I know that? Right here. There was my claim. It was the null. Okay, so let me just do this. So my claim was my null, and we fell in the fail to reject region. So what percent significance level? What was our alpha again? If I come back up here, my alpha was 0.01, which is the same thing as 1%. So we're going to say right here, at 1%. And then I'm going to use my little cheat sheet again. So our claim was our null, and we failed to reject. So we're going to say there is not enough evidence to reject the claim. There is not enough, so that there is not. And I think what they use here, guys, if I'm not mistaken, there is insufficient evidence to, what was it? To reject the claim. To reject the claim that the mean repair cost for model A is equal to or are equal to the mean repair cost for model B. Okay. So anyway, that is 8.1. Again, use the calculator, guys. It makes this doing this computation that much easier. I want you to notice that the rest of the problems, we're doing the same thing we did in chapter 7, okay? If y'all got any questions, please, please, please let me know.